Hello, my name is Nikolaos Sisifidis, and in this exercise an embedded house automation application has been built and programmed. The system is based on a Raspberry Pi 4B device, which offers a 4-core CPU, 4 GB of RAM, a complete and multitasking operating system, which is Raspberry Linux, network connectivity and Wi-Fi, and 28 GPIOs which support interrupts and special functions such as PWM. The software of the system is programmed in C, which allows greater control over low-level operations and precision timings while offering excellent thread support and mutexes. Moreover, this is my breadboard, which is connected directly to the Raspberry Pi, and now I'm going to explain all of the sensors that I have placed in. This is Blue Button, which is a simulator of the classical light switch that we have in our houses. If I press it, it turns on. If I press it again, it turns off. This is a magnetic switch, which is I'm going to use later. This is the green button, which is a simulator of the doorbell. You can hear it from the buzzer. This is an ultrasound sensor, and which you can get a measurement of the distance. This is a light sensor, in which if I go a lighter next to it, you can see on the screen that fire detected and fire extinguished. This is an obstacle detector. This is a PIR sensor, as known as a motion sensor, and here is my temperature sensor, the DHT11. So as you can see, this is my main menu. You can get a report of all of the sensors pressing number 1. Moreover, there's an option to change the yellow LED brightness. The acceptable range of numbers for brightness is from 0 to 100, type 50. As you can see, is on brightness 50%. Moreover, there's an option to toggle the alarm on with number 3. It displays activating alarm, and if I go and take out the magnet, it asks for a password, and if I don't type it in 10 seconds, it's going to ring. As you can hear, the buzzer is ringing because I haven't pressed the password. Moreover, there is an option to set low and high temperature thresholds in order to turn on the heating if the temperature is too low, or turn on the air conditioning if it's too high. Moreover, there's an option to set time to switch the yellow LED off. At this moment, the time is 24 to 9. I will set the time to 23 to 9. So, 5. So as you can see, the yellow LED is turned off because the time right now is 23 to 9. I can also get a measurement of the proximity sensor, as known as the ultrasound sensor, pressing number 6. It says 171 centimeters. It's the distance between me and the sensor. Um, there is also the PIR sensor, which which is a garage simulator using the obstacle detector, and this one, as I told you before. And if I go my hand through it, the red LED turned off and the green one turned on. And if I go my hand right here, I forgot to say that the garage door is opening. And if I go here, my hand next to the obstacle detector, as you can see, it says obstacle detected, and it's a simulation that a car passes through the sensor. And if I take out my hand, the red LED is turned on again, and the pathway is clear, and the garage door is closing. Moreover, there's a blue LED that is blinking, and this called as known as a heartbeat sensor that displays that my program is working properly. And it's there to be sure that I'm doing my work right. And the last sensor that I want to talk about is a CO2 sensor right here, and I have to make it more sensitive to work. Give me a minute. And as you can see here, if I blow to him, and wait a minute. When I blew it, it said CO2 levels critical and then CO2 levels normal. So this was my project at a home automation, and thank you for listening.